Hi students, so in last video we discussed about structure of atom. What are the subatomic particles? Those are protons, neutrons, electron. Who discovered them? What are their properties? We studied those. Discussed different models of atoms which were proposed by different scientists. The two major ones are Thomson's model. As you can see, it was what he proposed was that the structure is spherical, as you can see in the diagram, and that sphere is positively charged and negative charge is embedded in this. That was Thomson's model of atom, and it has its own drawback. Next, Rutherford's model we discuss, which you can see in the diagram. What he suggested that the whole positive charge is in the center and negative charge that is electron, those are revolving around it, but it has its own drawback. Even though his model was somewhat correct, but there were some drawbacks. He was unable to suggest how these electrons which are revolving around it are not able to lose its speed, or how they are not able to combine with the nucleus, how they are revolving. It was not explained by Rutherford. Now, based on Rutherford's model, Bohr started to make a structure of atoms, and his atom, what he said, that atom consists of heavy positively charged nucleus, which was suggested by Rutherford. He took that the same point. Next, the whole mass of the atom is concentrated in the nucleus. That was also suggested by Rutherford. So these point he took it from Rutherford's model, that nucleus is at the center and the main mass of atom is at the center, which was given by Rutherford. Now, Bohr specifically concentrated on electrons, how they are revolving. So the electrons and an atom revolves around nucleus in definite circles or path called orbit or energy level or shells. That was proposed by, so Rutherford suggested that. Next, energy levels is associated with a definite amount of energy. So these levels, they have specific energy. Once the electrons moves, then only they will release energy. When they are revolving, they don't release energy. Next, the change in energy take place when electrons jump from one energy level to another energy level. So they have different orbits, and once the electron move from their orbit, then only they release energy. If they are not moving from one orbit to another orbit, they don't release energy. They have fixed orbit, so once they are there, they don't have any energy to release. But when they move from the orbits, they release energy. So you can see in the diagram. So there are different energy levels of all the atoms of elements. So if so Bohr divided them into different shells or levels, 1, 2, 3, 4, and he named them as K, L, M, N. And from each level, when the electron moves, then only it releases energy, like you saw in the last diagram. This arrangement of electrons in different orbits or shells or energy levels, we call it as electronic configuration. And the maximum number of electrons that could be put in a particular shell or energy level was given by Bohr and Bury. Two scientists together, they gave this concept of how many electrons can sit in a single orbit. So as we discussed, the maximum number of electrons that can be accommodated in any energy level is given by 2n raised to square. So we have to put the number of orbit in n and we get the square, and when we into it with 2, we get the number of electrons that could sit in the orbit of K, L, M, N. The maximum number of electrons in outermost orbit will be 8 electrons if it has capacity to accommodate more electrons. So all the orbits which are there, that can hold maximum 8 electrons except the first one. So first one will only hold 2 electrons. After that, next all the orbits which are there of any atom or of element, they can hold maximum of 8 electrons. And electrons are not accommodated in a given shell unless earlier shells are filled, that is a stepwise filling of shells is followed. So it's not like they can sit anywhere. In class we can sit anywhere, na? Electrons cannot do that. They have to be systematic. The first bench has to be filled first, next the second, third, fourth. Likewise, in orbit also, the electrons should sit first closer to the nucleus, then the next orbit, then the next orbit, and the maximum first can hold 2, next 8, and next 8, next 8, like this. the electrons start to fill the orbits. It's a fixed number. There is no change in that. Now, how many electrons can hold, like we were discussing now, in a circular path around the nucleus is called orbit, energy level, or shells, and they are named in English alphabets by Bohr and Bury, K, L, M, N, O. And the first orbit we call it as K, second L, third M, fourth N, and so on. And now, how many of these orbits can hold electrons? So we can use the formula of 2n square, and you can see in the diagram that first orbit was called K, second orbit L, third M, fourth N, and the whole negative charge is in these orbits. Now, number of electrons, how much they can hold in this orbit, we can calculate. So the distribution of electrons in orbits, how we can calculate? We already got the formula from Bohr and Bury, 2n square. So number of electrons in K shells. So first orbit, how many electrons can it hold? Here the n is first. So the n means n represent the number of orbit, which number it is in series. So n, if we take the first orbit, which we named as K, so we fill the value of n. You can see in the example we get 1 square is 1, so 1 into 2 is 2. So the maximum number of electron in K shell, that is 2. 2 electrons can be hold in first orbit of any atom. Next, second shell, we named it as L. So L is second shell, so it is 2. So we fill the number 2 in n. So 2 square is 4. 4 into 2 is 8, and that's the capacity of the second orbit. Second orbit can hold maximum of 8 electrons. And likewise, all the orbits we number when we fill in Bohr and Bury's formula, we get the number of electrons that they can hold. But the last ring can hold maximum of 8 electrons. This diagram you can see the K, we already call it as first shell, can hold maximum of 2 electron, and that is the first energy level. Second orbit we call it as L. It has maximum of 8 electrons, which can hold, which we call it as second level of energy or second shell. Third M, fourth N, and they have their respective numbers. That much they can hold the electrons. The larger the atom, the more the electrons are there. As we discuss, there should be last 8 electrons, but all the atoms of the elements, they don't have 8 electrons in the last orbit. They are more or less. So some have 1, 2, or 3, 4, 5, 6, 7, 8, maximum 8. So the one who have 8 electrons, they are neutral. So they don't react with anyone. They are stable. But one who have less, they have to gain electrons from someone, and one who have more electrons, more than 8, in the next orbit they have 1 or 2, they lose electrons. So the electron present in the outermost shell of an atom, we call it as electron valency. So the electron valency can be determined the valency of the atom. So you can see in the example that there are different atoms like lithium, sodium, potassium, copper, gold, silver, and they have different atomic numbers. I hope you remember the atomic numbers which we have discussed. I gave you assignment too. So lithium has 30 electrons. So the first 2 are filled in the first orbit, and third one is in the second orbit in the first diagram. Lithium, Li, which you are seeing. So it has only 1 electron in the second orbit, but the capacity is of 8 electrons. So it has 1 extra electron. So it can lose it if you want. Same way, there are different orbits of different atoms who have last 1 orbit which they can lose. Likewise, the atom who have 7 electron in the last 1, they can gain. So that's how the reaction happens. So you can see in this structure of reaction, sodium has 1 extra electron in the last orbit, but chlorine has 7 electrons. You can count. So there are 7 electrons. So it need 1 more electron to become octave. So we call it as octave. We call it as octave, octet state, and that's how they become stable. And that's how the reaction happens. So when they don't have sufficient electrons in the last orbit to gain octet state, they get it from someone or give it to someone if they have extra, and that's how the compound forms. In this, you can see the sodium, which has extra electron in the last orbit, it has given it to chlorine, and chlorine has taken it. and now they have formed sodium chloride, NaCl. Like this, the compounds or mixtures are formed from atoms. So that is valencies. Valency is the combination capacity out of atom, the tendency to react and form molecules or compounds with atoms of the same or different elements. For the atoms having valency electron less than or equal to 4, valency is same as that of the number of valency of electrons in that atoms, like the valency of magnesium, which is 2. The number of valency of electron exceeding 4, like of oxygen, who has 8 electrons, but second orbit it has only 6, so it needs 2 more electrons to fulfill its octet state, so it gains the electrons. So that's how the positive and negative ions are formed. Okay, so if you have seen the periodic table, in periodic table we can see they are grouped based on their valencies. Okay, so first group which you can see, they all have one extra electron in their last orbit and they can lose it. Likewise, we have different orbits from 1 to 4 and then again minus. So the first one are all positive. So you can see in the chart what is the valency of the different elements which are there, which we know. So I hope you have learned by hearted your assignment. I have gave it to you now. So all the elements, their symbol and atomic number and their valencies. For reaction it is very important, you should remember them by heart. Now next concept is atomic number. So it's simple. Atomic number of element is equal to the number of proton present in the nucleus of an atom. So we know that Rutherford said all the positive charge or the mass of the atom is at the center, and that is due to protons and neutrons. So proton number, what is there in the center, we call it as atomic number. Since the atom is electrically neutral, thus the number of proton and the number of electrons are equal. So the atomic number, we give a symbol Z to it, the atomic number, and that is equal to the number of protons, and that is always equal to the number of electron also, but the mass of electron is negligible, so only we take proton as atomic mass. Now there are different things in an atom. So this is how we represent an elements symbolically. X, we take the elements symbol, Z at the subscript, which is atomic number, that is equal to proton number, and A is superscript, which is mass number, that is equal to the number of protons and neutrons. We already discussed this, that there are neutrons also along with the proton in the nucleus, which doesn't have charge but it has mass. So that's why, and we take the symbol A for the mass of neutron, and the sum of protons and neutron we call it as atomic mass or mass number. Last is isotopes. So atoms of the same element have some atomic number, but same atomic number but different mass number. To them we call it as isotopes. They are hydrogen, carbon, chlorine, different elements, iodines. They have different isotopes and they have different applications. You can see in this uranium, cobalt, iodine, they use in different ways. So this is one such example, like hydrogen. Even though they are all three are hydrogens, but you can see in the center, first one has only proton, second has proton and neutron, third has proton and 2 neutrons. So the mass is different, and that's how the isotopes are. Okay, like this, there are other isotopes, carbon and chlorine, iodine, and there is last concept, isobars. These atoms are of different elements. They are different elements, but they have same atomic mass. To them, we call them as isobars. And one example which is there is potassium and argon. They both have different atomic number but same mass number. You can see there is they have different proton numbers like 18, 19, 20, but neutrons are different, 22, 21, and the sum of that is total 40, 40, and that's how their mass is same but they are different elements, and this is isobars. So this concludes your chapter. If you have any doubt or question, let me know. Thank you.